Java 23 is here. Let's talk about what's in, what's not, as well as just a general overview of JDK 23's features and what you can expect if you were to start picking it up tomorrow. JDK 23 was released for general availability as of September 17th of 2024. With the current Oracle release schedule, this is a non-LTS or long-term support version, meaning that you can't expect this JDK to be maintained much past early 2025. Now, I'm not saying you should skip this version. I'm just saying that this is a non-LTS version. So if you are okay taking the newest features and trying them out, this JDK is for you. If you're looking for an LTS version of Java, you're going to want to go back to JDK 21. Or if you want to think forward, you'll want to look toward JDK 25 in the late 2025 timeframe per Oracle's current release schedule. Now let's get into the meat of this release. There are 4 things that I would consider new features as part of JDK 23. The first one, which in my opinion is one of the main takeaways of this release, is what's called primitive pattern matching. It's summarized in JEP, or JDK Enhancement Proposal number 455, and basically what you can think of it as is an extension of pattern matching to primitives. It's been added over various JDKs to make things like instance of and switch expressions more powerful. There's also record pattern matching, things like that. Basically, the big extension of JDK 23 is now applying that to primitives as well. So this is a good example of primitive pattern matching. For multiple reasons, the instance main method here, as well as the primitive pattern matching that we're doing in this switch expression, you need to make sure that you turn preview features on when you are compiling. Otherwise, your code won't even compile. And basically what's happening here is your primitive, your double, is part of the switch expression argument, and then you have all the different case labels here. You'll note that this is a complete switch expression, meaning that I don't have a default case, but I do have all of the cases covered that could represent the different situations that my primitive could enter. This is similar to how reference type pattern matching works with switch expressions, or if you were to use something like an instance of check, it's a similar concept. You can apply the same thing to primitives now, which is pretty cool. One of the main things that the language designers had to figure out with this feature was how to address safe versus unsafe casting. Let's say, for example, that you convert a double precision floating point number, which is 64 bits, down to a regular floating point number, which is only 32 bits. You could lose up to 32 bits of precision when you do that. That's not good. An easier example sometimes to picture too is, let's say that you have a billion, it's an integer, and you want to cast that down into a byte. Okay, so the byte value is going to overflow over and over again because a byte can't hold a billion. So it's going to just hold whatever bits the system accounts for as the byte representation of the 4-byte integer. So what's going to happen is when I'm evaluating the switch expression, the argument val here is going to go through the different case labels in order, and it's going to figure out which one it can fit into and do a safe cast with first. So when my value is 10, that can be interpreted as a byte. Therefore, it's going to evaluate the byte. If I were to up this to 1,000, now it is considered a short because short has 2 bytes of information and 2 bytes can hold 1,000. If I up it to 1,000,000, it is now an integer. If I up it to 1 billion, it is still an integer, but if I up it to 10 billion and I mark it as a long, but this is an interesting case where you can convert an integer literal into a floating point number and get exact precision, and it does work this way. So 100 billion cannot be converted into a float because the bits of the floating point specification don't line up properly to do that. So now we have to consider it a double. So just playing around here for a second, if 10 billion is acceptable, my guess is that 80 billion is also acceptable for float, and looks like it probably is, at least according to IntelliJ's diagnostics here. I haven't actually run this. But the point is, this is a cool feature that, in my opinion, is long overdue because we've been able to do pattern matching with reference types for a long time, but we have not been able to with primitive types. So thank you, Java language designers. This, in my opinion, is long overdue, and I'm excited to see it. The second major new thing is that JavaDoc now supports Markdown. Yes, Markdown. Bit of an interesting choice if you ask me, but when you think about it, it makes sense. When Java first came out in 1995, HTML was a pretty common thing that people would handwrite. And you would handwrite HTML code as part of like early web dev and that type of stuff. And it made sense to have documentation comments that would have something like JavaDoc generate them for you in a format like HTML, right? Well, these days, already almost 30 years later, the community has gotten closer and closer to more readable documentation that can still be interpreted as some form of code. And Markdown is one of those main methods now. Markdown's highly ubiquitous. It's very easy to read, and it's very understandable why someone would want to use that instead of HTML. So here we are. Now we have a way to generate HTML JavaDoc like we have for the last 30 years. And now we have this new method with Markdown. And all you have to do a Markdown comment is 3 forward slashes. And then you enter your Markdown, specifically in the common mark notation. If you want any more details on that particular feature, I'd recommend you check out JEP 467. The next new feature is module import declarations. This is documented in JEP 476, not to be confused with the 467 like the previous feature. The syntax here is really straightforward. Import module name. And it's really a pretty simple concept. Basically, any sort of publicly facing APIs that are included within the module are now imported into your source code file where you imported this module. Sounds great, right? Personally, in the Java projects that I work on, I'm a much bigger proponent of what's called a single type import, where you explicitly indicate each type that you want to import rather than importing a wildcard. And when I initially saw this feature, I was like, I don't know how I feel about that. But as you work on smaller Java projects, or you want to do some prototyping, or you have like a single source file project type thing, then this comes in a lot of handy. Because the reality is, when you're prototyping, you want what are called on-demand imports, so that you don't need to worry about typing out every single import that you need. You just want to make a generic import and move on. Now, this last one's a little interesting. Calling it a new feature is a little bit of a stretch, but basically, as documented in JEP 474, the ZGC, or the Z garbage collector, has 2 different forks to it effectively. There is the original version of the ZGC, then there is a mode called the generational mode. If you're not familiar, garbage collectors are generational or non-generational, where a generational garbage collector puts objects into different generations on the heap in order to save CPU time. Going into the details of the ZGC and GCs in general is outside of the scope of this video, but the basic idea is that the default GC that you get when you run with Java is the G1 GC. If you choose to use the ZGC, you need to understand as soon as you move to JDK 23 that you're going to use the generational mode by default, which for most of us is probably a good thing. If you have an application that is very particularly profiled to use the old version of the ZGC, you still have a way to use the old non-generational mode, but be warned that the generational mode is the new default and the old mode is getting deprecated, so you should plan on migrating that going forward. In addition to adding new features, JDK 23 also removed 2 major things. The first one, in my opinion, is another big takeaway from this release, is that string templates that were in JDK 22 are no more in JDK 23. Yeah, it's kind of a shame. If you have string template code in your JDK 22 code, you have to rip it out if you're going to use JDK 23. The reason is because in JDK 22, the team that was developing the feature got some good feedback both from the community and some internal testing to determine that the feature was not ready for prime time yet. So what they decided to do is remove the feature from the current release, JDK 23, and reevaluate it for a future release. The latest I've heard on this is that they intend to release it again in a future release with some major overhauls. As far as what release and what that looks like, to be determined. The second major piece of functionality getting removed in this release isn't really a removal so much as a deprecation. And that is a few of the methods within the Unsafe class. Now, if you're familiar with the Unsafe class, you'll know that it is, well, unsafe. But you'll also know that a lot of frameworks that you either depend on directly or transitively probably use some of this functionality. The specifics of what is getting removed and what the migration plan looks like is documented in JEP 471. It discusses deprecation of memory access methods within the Unsafe class. If you're actively using any of these APIs, don't worry. There is a migration plan, and the JEP talks about it, of what your different options are. Basically, you can use some of the JDK9 var handle API for some of it, or depending on your use case, you might need to use some of JDK22's memory segment API in order to handle those situations. I'd recommend you read up on that JEP and you understand the details of why the migration is happening, because it's an important migration to happen, because Unsafe is, well, unsafe for a reason. The remaining 7 updates in this release are what I'm going to consider less important, because they are what I would call continuations of prior JDKs. So for example, JDK 22 had a preview feature for the class file API. JDK 23 has a second preview of this API with some modest changes based off of user feedback. Check out JEP 466 if you want to read more on the class file API and some of the more nitty-gritty changes that are going on in that API in this release. Another feature getting its second preview is stream gatherers. Unlike the class file API, the stream gatherer's second preview has 0 changes relative to what was in JDK 22. So if you're already using gatherers in JDK 22, you should have no changes in JDK 23. For those aren't familiar, a stream gatherer you can think of as an intermediate operation for a collector. So the collectors, such as collectors.toList or just toList at the end of a stream pipeline, that would be a terminal operation. Sometimes you don't want to make a terminal operation, but you still want to collect your items, or in this case, gather them, before you do further things in your stream pipeline. And that's where gatherers come in. So the gatherer API made no changes from JDK 22 into this version because the community is looking for more feedback. So now's your time, if you have feedback on this feature, to give it before it becomes a finalized feature potentially. The next one is actually in its third preview, and that is implicitly declared classes and instance main methods. This has gone through a few changes over the previews, and the changes this time come down to a few what I'm going to call smaller details. The first one is actually that we're going to use the import module declarations that we talked about previously as a new addition to JDK 23. Basically how it works is when you have an implicitly declared class, at the top of that class, it's going to import module java.base. And that's going to allow for programmers to have to include even fewer imports in their first Java classes, and it's going to make Java, in theory, a lot easier to learn for the Java newcomers. In addition, there is a new class called java.io.io that provides 3 methods that are highly convenient for the new Java developer. The 3 methods are printLine, print, and readLine. I am way more excited about this readLine convenience method than I probably should be. But I remember when I first learned Java thinking, oh man, this is confusing. Why do I have to use this scanner? Or even better, buffered readers. Why do I have to use decorator pattern on basically one of my first Java programs? Yeah, didn't make a lot of sense. But instead, now I just get to use this little convenience method called readLine, which takes in input from system.in and puts it into a string for me. How convenient, right? The next 2 are also in their third previews, and they're kind of hand in hand depending on how you use them. The first one is structured concurrency, which is in JEP 480. And the second one is scoped values, which are in JEP 481. Structured concurrency is making 0 changes for this release. However, word on the street is that for JDK 24, they are looking to make some bigger changes to the API. So again, if you want to provide feedback to the community on how you like or don't like this feature, now is the time. Conversely, scoped values are making just one small change in the API as documented in JEP 481, where the call_where method now is going to take a functional interface, and the getWhere method is more or less unnecessary, so it is getting removed in the API now. Another feature is getting its second preview in JEP 482, and that is called flexible constructor bodies. Think of it as basically fewer rigid rules as far as what you can do before you have to call this or super. If you remember when you learned the process of constructor chaining and when you had to have your child classes call the parent classes and all those sorts of things, and how this and super work, that you had to call this and super in very particular orders to have guaranteed object construction and such. This feature basically allows a little more flexibility in what you can and can't do in the constructor body before you call the chained constructor either in this or in super. Since this is its second preview, the particular change in this version of the JDK is that they're also allowing you to instantiate fields of the class before you call all of the different chained constructors. Here's some code that demonstrates that. This code example comes mostly from the JEP, but we'll talk through the code a little bit here. So we're making a new instance of our subclass, which is right here, which extends a superclass. We have a final integer x, which is the field that we're talking about, and the sub constructor takes in the value of x that we want to set it to. Prior to JDK 23, we would not be able to do this. It would not compile. Instead, we would have to operate this way because superclass constructors have to be executed before anything within the child class constructor gets executed, or at least that's how it used to be. So with this version of the code, what's going to happen is the superclass constructor is going to get called right here, which is going to call this overridden method, which isn't going to call this implementation. It's going to call the child class implementation, and it's going to print a value of x here. And the value of x it's going to use is going to be the default value of what fields are initialized to, and that is 0, as we can see right here. Now, if we change the order around, like we can in JDK 23, we will see that the value now prints 1, because the argument that we passed into the constructor was the value 1. A bit of an interesting behavior change for what in this case seems like a one-off example. What do you think? Let me know in the comments. And we can't talk about a recent Java release without, of course, referencing the Vector API, which, by the way, in JDK 23 is in its 8th incubator. Yes, incubator, not preview. That means it's not even a preview feature yet. The reason it's been incubating so long is because, as stated in JEP 469, it's waiting on features as part of Project Valhalla to be part of the JDK and preview features. And once that's done, then in theory, the Vector API will then be a preview feature. And hopefully there aren't 8 previews after that. We'll have to see. So in total, in addition to the typical bug fixes and security improvements you would expect out of a Java release, there are 13 different major things that changed with this version. 4 of them are what I'm going to consider new features, with the ZGC being a little debatable on if it's actually a new feature versus just a migration of an existing feature. 2 features that were removed or marked for deprecation. And then 7 features that are continuations of existing things that are currently in development, are being incubated, or something like that. Overall, a pretty feature-rich JDK, if you ask me, given the 6-month release timeline that we're talking about with JDKs these days. But truthfully, I am also looking forward to JDKs 24 and 25, when ideally some of these previews can become full-fledged features. And later next year with JDK 25 when we have another LTS version. That's what I'm looking forward to. So, what are your thoughts on JDK 23? Anything in particular you're excited or not so jazzed about? Let me know in the comments below. If you enjoyed this video, please do smash that like button. I'd really appreciate it. Thank you for watching. I hope you have a good rest of your day, and I hope to see you next time. Take care.